Good afternoon, dear students. Our previous lesson was about the straight line on the plane, and our topic for today is plane in the space. And for now, let's have a look at different equations of the plane. So, reminding you some theoretical information. Uh, mhm. It's better. So this is the general equation of the plane. A, B, and C are coordinates of a normal vector. Uh, this is the vector that is perpendicular to the plane, and coordinates of the normal vector cannot be simultaneously zero. So it's a non-zero vector. So on the next form of the equation of the plane, so when we know the normal vector and the point that belongs it, so this formula, so a by x minus x with index 0 b and so on. So x 0, y 0, and z 0 are coordinates of the point m 0. That belongs P. And if we expand brackets, we will receive a general equation of the plane. The next form is equation of a plane passing 3 points. You know that 3 points, so that 3 points always are aligned at the one plane, in the one plane, so only one plane can pass through 3 points. So if we calculate the determinant, we will receive the general equation of the plane. Then intercept form. So A, B, and C, they are x, y, and z intercepts respectively. Then equation of the plane in the normal form. So cosine of alpha, cosine of beta, and cosine of gamma, they are direction cosines of normal vector. So to receive this form, we need to divide a general equation of the plane by magnitude of the normal vector. And then planes parallelism condition. So planes are parallel if and only if their normal vector coordinates are proportional, and they are perpendicular if scalar product of these planes is zero. So just perpendicularity of vectors. So you remember this information already. So distance between the plane and point, so we take magnitude from scalar product of the point and normal vector plus free coefficient d, and divide it by the magnitude of normal vector. So how to receive cosine of angle between planes P1 and P2? The same. So as we remember, scalar product of vectors topic. So we divide scalar product of normal vectors by the product of their magnitudes. Maybe any questions about theory for now? If no questions, let's rock. So the first task. By the way, is such Zoom okay for you, or you don't see the text?
Which text?
Everything is fine.
Okay, everything is fine, so continuing. Yeah, it will be more convenient if you have enough space. So if all equations will be in front of you every time, so all the lesson. Okay, so the task is the next. We need to write down the equation of the plane P that is passing through the point M and parallel to another plane Q. How to solve? Which equation can we take? Do we have everything for this. So, any ideas? Okay, everyone is shy. Sophia?
I guess we should take the second equation.
Yeah,
And
so
also,
this one.
uh,
Mhm.
and also the normal vectors are equal because planes are parallel.
Correct. Yeah, so we can use normal vector of Q. So let's write it that NP equals NQ, and it equals 5 minus 1 and 3. Okay. And we know coordinates of the point M, so writing down the equation. 5x minus 2 minus y minus 3 plus 3 by z plus 1, and it equals 0. Now let's expand brackets. So 5x minus 10 minus y plus 3 plus 3z and plus 3. And it equals 0. And finally, so the general form plus 3z and the free coefficient minus 4. So this is the final answer. Basically, this can be as final answer as well. So this is the equation of the plane, and nothing mentioned about the form. So should it be general? So should we expand it or not? Okay. So next task. Maybe any questions about this task or no questions? Okay. So
I have.
oh,
Oh, all right.
okay. Return
Um,
back.
where did -5 go from a Q equation?
-5. Why -5?
In the equation, we have 5x minus y plus 3z minus 5. Where did it go?
Now this is a free coefficient of the plane Q. We don't need it.
Uh-huh.
We are writing down for the plane P, and the free coefficient for this plane is other
Okay,
-4.
thank you.
More questions? Okay, no questions. So moving next. So the next task is to write down equation of plane P that is passing through 2 points and parallel to vector A. Any ideas how to solve? By the way, we have 2 ways to solve it. Yeah, it's quite complicated can be. Uh, But okay, so I will explain how to solve. So what we need to write down the equation of the plane P. So uh, we have only 2 points. That's not enough because we can uh, draw infinite number of planes through 2 points. Also, we don't have a normal vector. So we need, first of all, we need to find the normal vector of this plane. How to do it? So points M1 and M2 are aligned in the plane P, And we also know that it's let's write it in the vector form. So the first way, first solution. So m1, m2 vector. It's a vector that belongs to P. And by the way, m1 and m2. Okay, that's enough. Now we don't know if it's parallel to vector A or not. With the vector m1 and m2, we can receive a vector, a normal vector. And how can we receive? So any ideas? So let's remember vector products. Okay, I will remind you. Normal vector is so can be received as a cross product of two vectors m1 and m1, m2, and a. So as you remember, it's perpendicular to both these vectors, so it's perpendicular to the plane P. So let's calculate. Okay, calculating vector m1, m2. So -1, 1, 0. And vector A, 2, 0, 1. So I 0, 0, nice. I minus 2k. Stop, 0. Mhm. Let's recalculate. So for the first diagonal, correct, 0 and 0 for this triangle. Okay. For the secondary diagonal, minus 2k, 0 triangle, and plus j. And it has coordinates 1, 1, minus 2. Okay. Yeah, 1, 1, minus 2. Okay, so we have a normal vector, and we have even 2 points that belongs the plane P. Which one do you want to use to write down the equation of the plane P? So it will be your choice.
M1.
Okay, let's go with M1. So plane P equation is the following. X minus 1 plus y minus 1 minus 2 z minus 1, and it equals 0. Let's expand. So x plus y minus 2z. So minus 1 minus 1 minus 2 plus 2. Okay, so equals 0. So free coefficient d is equal to 0. And this is the equation of the plane P. Any questions about such a solution, such way? Okay. Okay, then next, what we're doing. So the second way, so taking a point with, so just point M, we don't know coordinates, with coordinates m, so x, y, and z. And do you remember uh, when three vectors are coplanar? By the way, what does it mean? Okay, I will remind you, three vectors are called coplanar if they can be aligned in the one plane. And the condition, three vectors are coplanar if and only if their mixed product is zero. So we need two vectors. We already know vector A, vector M1, M2, and we also need vector. Okay, let's take M1M, and it will have coordinates x minus 1, y minus 1, z minus 1. And now let's write the mixed product of these vectors. So this is the following determinant. And I will just copy and paste these values. So what we have? X minus 1. 0, 0, minus 2, z minus 1, 0 here, and yes, no, 0 for x, and plus y minus 1, so and it equals 0. So basically, as we can see, it matches such equation. So we won't waste the time for expanding brackets. Yeah, and just let's write down it as the final answer, that it is the plane of equation P. So just for understanding what we received. Any questions about such kind of solution? Which do you prefer? The first one with receiving a normal vector, or with this one? So the second. Sophia?
For me, the first one is more understandable, to be honest.
Well, I like the first one more. Uh, yeah, I agree with you, because yeah, we need to do less actions. So yeah, that's why it's easier. Yeah, I agree with you, but it's better to know different ways how to solve the task. Okay, maybe more questions. If no questions, moving to the next task. So the task number 3, we need to write down equation of the plane passing through points M1, M2, and M3. So which from to use? So who hasn't answered yet and can quickly answer this question? Dmitro?
So we need to use the equation of a plane passing the 3 points.
Yeah, because we need everything for it. Of course, we can do the same that we were doing before, find vectors m1, m2, m1, and m3, then find the normal vector, but yeah, it will be easier for us to use this form. Okay. So, writing down the equation. And be careful so that every time we subtract x1, y1, and z1. So, coordinates of the first point that we choose. So, x minus 3, y plus 1, z minus 2. So, for the first row, we are subtracting from variables. Subtracting coordinates of the first point from variables. And for the second and for the third row, we are subtracting coordinates of the first point from the second and the third, so respectively. So be careful with that. Don't confuse points, indices. Okay, so now I'm writing everything in details. 4 minus 2, 4 minus 3, 2 minus 3, then now minus 1 plus 1, 0 plus 1, then 2 minus 2. Oh, no, yeah, 2 minus 2, correct. No, minus 1, minus 2 here. So don't confuse coordinates, and 2 minus 2. So checking that everything is correct for now. And this equation of the plane P. So 4 minus 3, 2 minus 3. Okay, minus 1 plus 1, 0 plus 1. Then minus 1, minus 2, 2 minus 2. Okay, so continuing. And now it's simplified. So let's subtract all numbers. So 1 minus 1, 0, 1, minus 3, and 0. Okay, and now calculating the determinant. Okay, we'll erase P just not to, щоб не заважало. Okay, so 0, 3 y by y plus 1 plus z minus 2 0 plus 3 x minus 3 and 0 for y, so it equals 0. So finally, oh yeah, let's expand the brackets. So 3x minus 9 plus 3y plus 3 plus z minus 2, oh, minus 2, not minus 1, and it equals 0. And finally, the general equation, so 3x plus 3y plus z, so minus 11 plus 3 minus 8 equals 0. And let's verify the answer. Yeah, 3x plus 3y plus z minus 8 equals 0. So correct everything. Okay. Any questions about this task? So basically, as for me, it's the easiest case, maybe uh, of the plane. So when we have only 3 points, yeah, but of course, calculation of determinant. So maybe the easiest task when finding with normal vector and the plane. So now we need to define intercepts of the plane 2x minus 3y plus 8z minus 4, and we need to demonstrate everything graphically. So how to solve? Your ideas, suggestions? By the way, it's so formulas that we need are in front of you. So basically one formula that we need. So which how should we transform the equation, reduce it? Okay, so no ideas. Basically, Sophia, yeah?
Use the equation of the plane in the intercept form.
Yeah, so we need to rewrite this equation to receive the intercept form. Correct. So let's start. So first of all, moving coefficient coefficient 4 to the right side. And then we just need to divide both parts by 4 to receive 1 here. So x by 2 minus 3y by 4 plus 2z equals 1. And now let's rewrite to see all intercepts correctly. So x minus 2 plus y divided by minus 4 third plus z divided by 1 second. And it equals 1. So we can see the intercepts with of the plane, this plane. So x-intercept is 2, y-intercept is minus 4 by 3, and z-intercept is 1 second. And now let's build the graph. So let's write both general equation and so build the graph by general equation and by intercept form to verify that everything is correct. So x by 2 plus y by minus 4 third plus z by 1 second equals 1. So as we see, graphs match, so everything is correct. And now let me make graphic transparent just to see how it looks like. Yeah, x's are not so we have different orientation of x's, but anyway, it's not a problem for us. And now let's mark intercept points. Yeah, intercept with the intercepts of this plane. So first intercept is 2, 0, 0. So this one found. Can we label it? It seems that cannot. Okay, that's not a problem for us. So y-intercept minus 4 by 3, 0. So found y-intercept. And then z-intercept, 0, 0, 1 second. So all intercepts are found, as we can see. So everything is correct. Any questions about this task? Yeah, here is the graph as well. Yeah, it's not maybe so convenient, but okay, we can see labels and basically drawn intercepts. So any questions? No questions?
No questions.
Okay, no questions. So moving to the task number 5. So we need to write down equation of the plane perpendicular to OZ axis. So it means so OZ. So it is parallel to x or y coordinate plane. So and it passes through the following point M with coordinates 1, -3, and -2 and 3. So what is so we have the point, and we need a normal vector. And how to find it? Or maybe we have already normal vector, but it's not written in the such in the condition. So that normal vector is, but we can already understand it from the condition. So as it is perpendicular to OZ, what can be taken as a normal vector. So no ideas. Well, as the plane is perpendicular to OZ, it means that we can take a unit vector that corresponds z-axis. So it has coordinates 0, 0, 1. And our equation has the following form. So z minus 3 equals 0. And that's it. Or just so z minus 3 equals 0. And where is the plane? Okay, let's play with scale. Yeah, so as we can see, it's perpendicular to z-axis. And that's it. So quick task, quick solution. Maybe any questions about this task? So sometimes we just need to be attentive with the region conditions. Okay, as no questions, moving to the next task. And task number 6, we need to calculate the distance between point M, M0, and the plane. Okay, let's move it up. So here is the formula that we need to use. So we have everything, all the information to solve this task. So now let's just calculate distance. So M0 P, so distance is calculated by the next formula. So 2 by 3 minus 4 plus 2 by -7 -9. Yeah, and everything is, so we take magnitude from it. And here 4 plus 1 plus 4. By the way, nice square root. So, well, what we have here? 6 minus 4 is 2. Then minus 4 minus 4. 2 minus 14 is minus 12. Minus 12 minus 9 is square, so is 21. So 21 by square root of 9, so it's basically 21 by 7, or 21 by 3, and the final answer is 7. So nice. Easy to calculate. Any questions about this task? Okay, no questions, so moving to the next task. Number 6. So we have the pyramid with uh, with the given vertices. So we have coordinates of vertices, and we need to find not height, altitude. I need to correct it after that. So let's first of all draw the pyramid just for our convenience, for better understanding. I guess that it will be helpful. Okay, and let's assign vertices. So yeah, D will be here. So A, B, C, and D. Yeah, and also let's join vertices D and C. Maybe it will be useful for us. Okay. So, any ideas how to solve? So we need to find this this distance. Okay, maybe anybody else wants to participate in the discussion. Bogdan, yeah, haven't heard you for ages.
So we can find the equation of plane ABC,
And
have-
then,
point D, and then use the formula for distance.
yeah, so we need to find the equation of this plane ABC. So based on these points, and then we just find in the distance with the proper formula, with this formula. And equation, I won't ask you which to use, because it's obvious that we will use this determinant, because we know 4 points. So let's start. Let's find it. So x minus let me copy and paste it. So is the drawing is helpful for you or not, by the way? So makes it more understandable for you. If so, draw a lot as you can if it when solving your tasks. Of course, if it's useful for you, if it's helpful. 3 minus 4, 1 minus 4, and 1 minus 1. Okay, let's double check. So 4 minus 3 minus 4 minus 3. Okay. By the way, don't forget, do double check of the determinant because it's the common mistake. So minus 3 minus 4, 1 minus 4. Okay, 1 minus 1. It seems that everything is correct. And now let's simplify it. Reduce. So 1 minus 7 minus 7 minus 3, 1 minus 1. Okay, so 7 by x minus 3 minus 7 by y minus 4 and minus 3 by minus 3z. Then our secondary diagonal minus 49z plus 3x minus 3, and then plus y minus 4. And now let's start reducing. So then what we have, 10 by x minus 3 minus 6 by y minus 4 minus 52z equals 0. By the way, let me check if everything was calculated correctly. Just yeah, correct. So now let's also we can simplify this equation by dividing by 2. So just instead of having large numbers, of course it's always convenient if numbers are less. So 5 by x minus 3 minus 3 and minus 26. And now expanding brackets. So, by the way, we don't even need to expand them. We have everything that we need. So we know A, B, and C. So normal vector that equals 5 minus 3 minus 26. So that's enough. And coordinates of the point D. So that's all what we need. We don't need anything more. So finding a distance between D and P. No, we need to expand because we need coefficient D. Free coefficient, we need to know it. So, yeah. That's my laziness. So 5x minus 15 minus 3y plus 12 minus 26z equals 0. Yeah, so minus 5x minus 3y minus 26z minus 3 equals 0. Yeah, so we need this coefficient in explicit form. So 5 by minus 1, so minus 5, plus 3 minus 130 minus 3. And then we have 25 plus 9 plus 666. So basically, that's the answer. Finally, we will receive such such answer. So 135 divided by square root of 710. So it makes no sense to play with the square roots. So that's what we had to find. Any questions about this task? No questions, right? Okay, now let's solve one more quick task, and after that we will have a break. So task number 8, it's not big. So we need to find the angle between 2 planes. So how to solve? We remember that we need to find product, so scalar product of normal vectors, and then divide by product of their magnitude. So let's calculate. So minus, okay, so 4 by minus 11, so let's write in details. Then we will expand everything. Minus 10 by 8 plus 7. And divide by, so 16 plus 100 plus 1 multiplied by 121 plus 64 plus 49. So minus 44 minus 80 plus 7. And square root of, so 117 by 170 plus 64 by 234. And here we have minus 117, by the way. So it seems that the angle is the table value. So minus square root of 117 by 234. And that's minus, yeah, so we can see that if we reduce, we have, so minus 1 by square root of 2. And that's a table value, phi equals 3p by 4. Any questions? Oh, no, not 3p by 4. Oh, yeah, 3p by 4. Correct. So any questions about this task or no questions?
No.
Okay, now let's have a break. And after 5 minutes, we will continue finding equations of the plane. Okay, let's continue. So the next task, task number 9, we need to find intersection point of 3 planes. So each so 2 planes are intersected by the straight line. And if we have 3 planes that all of them are not parallel between each other, they always have one common point. So we have 3 planes, and we need to find their intersection point. And how to solve it? Any ideas? What do we have to do? Bogdan?
Well, we could make a system of equations,
Yeah,
of
correct.
all those planes and solve it.
Correct. Okay, and which method do you suggest? So who can suggest?
Yeah, we could use matrices, I think.
So matrices, yeah, and which which method with so related to matrices?
Maybe Gaussian elimination method.
Okay, yeah, let's go with Gaussian elimination. So Cramer method you have here when reviewing the lesson, you can see it. And now let's use Gaussian method. But method of inverse matrix is quite long, so Gaussian should be faster. Okay, and now let's start elimination. Let me expand. Let me maximize for convenience. So what I prefer to do? So now this row will remain without changes for now, and I will subtract it from the second and from the third. So here we have 1, 3, 2, and 1. And this here we can already eliminate for. So 3 plus 8, 11. Plus minus 6, so minus 2, and minus 2 here. Okay, continue. So moving this equation here. So some kind of nostalgia, all right? So eliminating this row. So 0, and here minus 6, so minus 10. Minus 1, and minus 1. And now I will add the second, the third row to the second. So what I will receive, we'll just add them. So 1 minus 3 minus 3. And now let's eliminate the last row. So 20. So 2 minus 2 plus 33. So 31. And the same 31. So what do we have? By the way, we can find that already. So z equals 1. And then y equals minus 3 plus 3z, it equals 0. X equals 1 minus 3 y minus 2z. So y is 0, as we already know. So 1 minus 2 equals minus 1. And finally, coordinates over point M are the following: minus 1, 0, 1. Yeah, don't confuse order of coordinates because for Gaussian method we start solving from the bottom to the top. So inverse solution. Okay, any questions about this task? No questions. And let's verify. Yes, so minus 1, 0, 1. So the same solutions. Okay, as no questions, let's move next. I'll minimize it again. So task number 10, we need to find to write down the equation of the plane passing through the point K and parallel to the plane Q that passing through 3 points. How to solve? So do we have so what we need to write down equation of the plane P? We have the point passing that belongs plane P, but that's not enough for us to write down the final equation. So what else do we need for the plane P? Any ideas, suggestions, Sophia?
I guess we need a normal vector, and as they're parallel, the normal vector will be like they will be equal to each other.
Right. So NP is equal to NQ. And how to find normal vector over NQ? We just need to write down the equation of plane Q, and we have everything for it. So 3 points are known. So just writing down this equation. So x minus 4, y plus 3, z minus 1. And then, so 3 minus 4, minus 1 minus 4. And here minus 3, oh, stop, 4 plus 3, minus 1 plus 3. Minus 1 5 minus 1. Okay. Let's erase it. Not equals 0 and this as well. So, but by the way, let's double check. So x minus 4, then 3 minus 4 minus 1 minus 4. Okay. Y plus 3, 4 plus 3 minus 1 plus 3. And, z minus 1, 0 minus 1, 5 minus 1. Okay. So that will be a good practice for you as well to double check everything, because it's painful to receive the incorrect final result. Okay, so 28 x minus 4 plus 5 by y plus 3 minus 2 by z minus 1. Then plus 35 z minus 1 plus 4 y plus 3. Okay, more space. And plus 2 x minus 4. And now let's simplify it. So I will just calculate, add all coefficients before brackets. So 4x 28 plus 2, so 30. Then 5 plus 4, 9. And 35 minus 2 plus 33. So, and it equals 0. And we basically can reduce it. So finally, so we can divide everything by 3. Just to simplify all calculations in the future. So 10, 3, 11. And that's the equation of the plane Q. So the normal vector for P equals 10, 3, 11. And for this task, we don't expand brackets. So all what we need, a normal vector and point K that we already have. And what is going on? And with all this information, let's write down the equation of the plane P. So 10 by x minus 1 plus 3 by y minus 5 plus 11 by z minus 2, and it equals 0. So let's leave it in such form to save our time and to have more time for solving other tasks. Any questions about this exercise? Or no questions?
No questions.
Okay, no questions. So now let's move to the next task, task number 11. Task is the following. So we need to write down the equation of the plane. Such a surprise. And it's parallel to OX axis and passes through 2 points, M and N. So we have 2 points. It's not enough for the plane. Not enough information, and but we know that it's parallel to axis OX. So how can we solve? We had the task similar to it already. So how can we find a normal vector of the plane P? Well, so in Sophia and who other yeah, so okay, let's decide. So
Go.
just
Oh, okay, so parallel to OX, it means that the vector will be 1, 0, 0. And we can find the normal vector by multiplying mn by this vector 1, 0, 0.
correct. So cross product of vector mn and unit vector I. So yeah, that's just what we need. We would solve it in one way. It will be enough, and it's even easier than the task before because not not a lot of calculations. So vector mn. So coordinates 4, 2, and -4. And here just 0, 1, 0, and 0. So quite a lot of zeros. So 0, then -4j, 0, then -2k, then 0 and 0. So that's just what we have. So -4 and -2. Oh, no. 0, -4, and then -2. So let's be attentive. And we can also move -2 out of brackets. So 0, 2, 1. And so instead of reducing the equation, let's simplify normal vector for it. So it will be okay to use for us vector with the coordinates of so 0 to 1. So NP, let's write it in such way. So yeah, I even will erase n here. So like just cross product, and normal vector will be just 0, 2, 1. So simplifying our life, basically part of our life related to this task. So normal vector we have, and now let's choose either point M or point N. I suggest you to choose the point. Which of them do you want to use?
Let's use point M.
Point M? Right, okay.
Yeah.
Let's go with point
Yep.
M. So equation of the plane P. So skipping x, so 2 by y minus 1 plus 0 minus 2, and it equals 0. And finally, 2y plus 0 minus 4 equals 0. And with verifying, yeah, 2y plus z minus 4 equals 0. So that's the final result. Then, so any questions about this task or no questions? If not, let's move next. Oh, Bogdan, yeah?
Yeah, I have a question about normal vector. So when we put -2 out of the brackets, then we just remove 2.
We just reduced it by 2.
And-
We can see
Mhm.
here. So here I didn't move -2 out of brackets, and what we have -4, -2, and after that just reduced it. So it's easier to simplify normal vector before than
Oh yeah,
simplify the whole equation. So
I see that.
yeah, so but this way is simpler than here. Okay.
Okay, thank you.
You're welcome. More questions? Okay, if no questions, let's move next. So it's final task for today, task number 12. So we need to examine a mutual location arrangement of 2 planes. So if they're parallel, we need to find distance between planes. If not, cosine of the angle between them. So yeah, by the way, I forgot to copy and paste conditions. So let's start with the A, of course. Yeah, here let's be attentive. Some of variables are missing, so it means some coordinates of normal vector are 0. Okay, now let's examine. So A1 divided by A2 equals 0, and B2 divided by B1 equals 1 second. So it means that planes P1 and P2 are not parallel. It means that we can calculate the cosine of angle between them. So now let's calculate the scalar product. So minus 1 by 0 plus 2 by 1 minus 1 by 3. And divide by a product of magnitudes. So 1 plus 4 plus 1 multiplied by so 1 plus 9. So what we have 2 minus 3, so minus 1 divided by 6 by 10. Well, we can move 4 out of the root, extract 4, and that's it. So 2 square roots of minus 1 divided by 2 square roots of 15. Yeah, so that's correct. And so any questions about this task or no questions? So about part A, basically.
No.
No questions. Okay, let's move to B. So A1 by A2 equals minus 1 second. B1 by B2 equals minus 1 second. C1 by C2 surprisingly equals minus 1 second. Yeah, and and now let's do the next. Now let's calculate the distance between planes. I have a question how to calculate distance between the planes. So we don't have a specific formula for distance, but we can do something else for it. So your ideas, suggestions how to solve? What can we do? Sophia? Sophia and Bogdan. So others are shy. Okay. So any of you feel free to answer. Or maybe anybody else who I haven't heard for a long time. Okay, just anyone without raising hand, please answer. Share your ideas.
Well, we can simply take a point that lies on the plane.
Yes, so we can take any point from any plane and then calculate the distance between this point and another plane. So basically, equation of the plane P1 looks more convenient to select the point. And now let's try. So, for example, so let's choose the point here already. So yeah, so with the coordinates -1, -1, 2. Okay, let's use this point. Oh no, let's choose another point and then compare results. I guess it will be more interesting. So, for example, 1, 1, and 0. So yeah, 2 -1 -1 equals 0. Let's go with this point. So what we have? So -4, -4, +2, -1, and then 16 +4 +4. So -5 +2, so 3 by so square root of 24. Yeah, of course we can move something from the brackets. So 6 by 4. Oh, yeah, so we can extract 4. So 3 by 2 square roots of 6. And by the way, as we can see, different points, but the result is the same. So you agree that it's more interesting to choose another option. Any questions about this task, about the whole lesson or previous lessons, previous topics? Sophia?
I don't have questions about these tasks. Can you please open individual home tasks? Because they're not.
Yeah, I will try not to forget today, but let me write down, not to forget. Thanks for reminding. Yeah, the third group on the next lesson also will remind me, so I won't forget. Don't worry. More questions? Okay, if not, no questions, have a nice day. Stay safe. Thank you for your attention. The recording will be available
Goodbye.
soon. Goodbye.
Thank you for the lesson.
Thank you
Goodbye.
for the
Have a nice
lesson. Thank you
day.
for the lesson. Take care.